Great. We'll go ahead and get started. All right, so we're on day 2 already. We're going to start with reproducibility here. Okay, so what is reproducibility? This is some content that's adapted from our colleague Candace Savanen, which does a lot of work in this area. So a lot of us will get to a point with our data analyses. Things are looking pretty good. We're getting results that look nice, and we're ready to send it out to the field. But it's important to take some steps first to make sure that first it's repeatable. So that if you yourself takes your code and your data, you can get the same results multiple times. And ideally, we're talking the entire process from start to finish. When we talk about reproducibility, we're talking about taking our data and our code, but giving it to someone else. And do they get the same results? And this helps us to get to something that's extremely important in science, which is replicability. So can we take new data and do a similar analysis and get the same result? That, for example, variable A and B appear to be positively correlated. So these are really in a hierarchy structure or hierarchical structure where repeatability is the easiest. It takes the least effort, the least time, but it's essential for getting to the step of reproducibility. And then, of course, replicability takes the most effort and time. So why is this so important? I mean, obviously, we know that replicability is something we need in science. But, we can have situations where we run the code, it seems like it's working pretty well. We hand it to our collaborator and they get a slightly different answer, or maybe their plots look a little bit different. And then it's hard to know which one's right. So it takes a little bit of time to set up the processes to make things much more reproducible, but it really has a lot of payoff. So it's worth that extra effort and it can save you a lot of time in the long run. So it's sort of a tortoise and the hare kind of situation. And it can be a really nice thing for yourself in the future. So say you run your code today, in 6 months from now, 6 years from now, are you going to be able to understand what your code was doing? Are you going to be able to run it and have it work successfully? So the process generally is getting your code to work once for yourself. You have that RMD file, maybe you get it to run inside the file, but you haven't tried to knit the document. And so you get the code eventually working with that knit button. You can reliably do it again and again. And, ideally, again, we're talking from start to finish with your data analysis. And then you might hand it to a colleague or a friend to see if they can make sure that they're also getting the same result. So this is why our Markdown notebooks are so handy. This is a much better process than it would be if you were using our scripts. So it allows you to interactively test your code because you get to run those chunks and see what the output is, or you get to knit the full document and see, am I getting the results that I expected? Is it rendering? Is it working? It also allows you to really show what you did. So you can put the results right next to the code. So your colleague or your collaborator, they can really easily read through and figure out exactly what you did. And it can make it really easy to update something. So say it's late at night, you're trying to finish a poster, you're going to a conference, and you had this data analysis, you're adding a few more samples or something like that. You can much more easily set it up so that you're rerunning your analysis and getting your results much quicker than in other cases. So there are some practical tips that can help us to ensure that our code is complete, that we have everything that we need there, that it's working properly. And one thing to do for that is cleaning our environment. So in our environment, there's this little tiny broom button. When you hover over it, it says clear objects from the workspace. And it's a good idea to occasionally do this once we're sure that we've written our code down that we need. And then when we try to check whether we really did do that by running our chunks, we can tell, oh, actually, I forgot to load one of the data sets in or something like that. And so this is a really good practice to make sure that we're not missing anything in our code, or, oh, I modified the data in the step that I did interactively in the console, but I forgot to copy paste that code into the R Markdown file. And so now it's not working like I expected. That's what this button is for. And then again, when we knit our file, it's using its own environment. So it's not relying on anything that we've been doing interactively. So that's also a really good option for testing our code. And, put notes in there and provide sufficient detail so people and your future self can understand exactly what you did. That can be extremely helpful. And I would err on the side of too much. I often find in data analyses later on, I'll be like, wait, where did that data come from? What was I using exactly? So especially when we're talking about what data we're using, would err on the side of extra data or extra information. We'll also see further on that we'll be, in some cases, and we've already done this a little bit, creating random numbers. And so when we do that, sometimes we want to have the same random numbers show up every time. They're actually technically what's called pseudo-random. So there's this function called setSeed that helps to set the starting state for how the random number generator creates the random sample. So for example, if we use setSeed 1, 2, 3, we're going to get a sample of 3 numbers that looks like this. So we have 3, 10, 2, etc. If I run that exact code again, my random sample, as you can see, is identical to the last random sample. So this is great because if I hand my code to Ava, she can run the results and get the same exact output. Note that if we used a different seed, like 4, 5, 6, we're going to get a different output. So it's all about having the same seed as each other. And if we don't set a seed, it's just going to be a random sequence of numbers each time. There's a lot of complicated computational theory and math behind how these are generated. So if you're really interested, I suggest looking up the link here. Also, in our Markdown files, we can make these really beautiful reports that we can hand off to our colleagues and collaborators. And we can do a lot in the syntax to change the way that it looks. So we were working a little bit with these headers in our lab yesterday. And so a smaller header will have more hashtags or hash symbols in front of the text, whereas the largest header will have just a single hash. And you need a space in between the text and the hash symbol. We can bold text by putting italics around words, or we can make them not italics. We can bold text by putting the asterisks around words. We need 2 of them on each side, or a single one will make it italicized. And we can use backticks if we want to refer to code. But typically our code's going to be inside of those chunks, and then we don't need backticks for those. But here you can see what the output is here. We have a large header, smaller subheader, bold text, italicized text, and that code text. If you're interested in learning more about how to make your reports look really nice, there's a really great cheat sheet that you can actually get inside of RStudio itself by going to Help and Cheat Sheets. But also our class website has the cheat sheets as well as these slides. Also, the versions that we're using matter. So as you may have noticed, we asked you to install the current versions of everything. And that's because this can influence our results a bit. And the reason that this happens is that the default settings for how certain calculations are done can be different from one version of a package to another. And so having the same consistent RStudio, R, and all the various packages that you might be using, all of that can be really important for getting the same result. And so it can be really helpful to let people know what versions of things you're using. And we can really simply do that by using a function called session info. And that'll really easily just print out everything that we're using. So here one person says that they have this version of R, whereas this other person has a different version. It will show your operating system as well as the versions of each of the packages that you're using. And all you have to do is run this with nothing inside the parentheses. So you can add that at the bottom of your R Markdown files. All right, so let's do a simple gut check here. Why is reproducibility so important? Is it A, because it helps ensure that your code is working consistently and it helps others understand what you did? Or is it B, it ensures that your code is correct? Very nice. Yes, the answer is A. So just because we're following reproducible practices, and maybe we have really, really great reproducible code, it does not necessarily mean that it is correct. But we can't get to a place of knowing if it's correct if it's not reproducible. So this is the first step to rigorous science. All right. And what is not a practice to improve the reproducibility of our work? Is it A, using R Markdown files to describe what our code is doing? B, using scripts instead of R Markdown files? C, testing our code with R Markdown files and the run previous button? Or D, regularly cleaning the environment? That's right. The correct answer is B. So using scripts instead of our Markdown files is not a practice necessarily to improve your reproducibility, at least in the way that we're describing here. And enables us to really track what we've been doing, describe that to others, and test what we're doing. There are a lot of other resources that you can use to learn more about reproducibility if this is something that's interesting. So the first two here are written by our colleague Candace Savanen, and they kind of go together and build off one another, and the advanced course obviously gets more advanced. So in summary, to help make your work more reproducible, you can use those R Markdown files. You can clean your environment regularly. You can check the knit of your R Markdown, making sure that it's able to actually knit. And before that step, you can try running the run previous button of your chunks and try running it in your current environment. You can write down in your R Markdown file what you're doing so that you in the future and your other colleagues know what you did. And you can use that session info function to know what versions you used. Are there any questions about this before we go into the lab? Also, we have cheat sheets here. So we have our own cheat sheets from the class, as well as a cheat sheet from RStudio, which will show you all the various fancy R Markdown things you can do. Okay, we will jump into the lab.
And we are going to the website. So we just talked about reproducibility a bit just now. And so let's download the lab RMD file. So we've been talking a lot about RStudio and reproducibility and that kind of thing, which RMD files or R Markdown files are going to help with. Okay. And all right. I'll give everyone a moment to grab this and just make sure you're on the same page as me. All right, so let's create two objects in our environment. x and y. We'll assign x as a vector of numbers 1, 2, and 3. So let's do that first. Give us a moment to do that. All right, what do we think? How would we make a vector called x? What do we have to start with on the left side here? Yeah, exactly. So whenever we're doing an assignment, we want the name of something on the left with the left arrow. And yeah, exactly. So yeah, we'll want to combine those numbers and we'll want to separate them with commas. Yeah, exactly. All right. And same thing with y. I want to do 4, 5, and 6. So y is going to be same thing, basically making yet another vector, but just different contents. 4, 5, and 6. All right, so we have a couple options. Remember we learned yesterday that we can type the code here in the file and save it for later, right? If we save this R Markdown file, I can come back to this code at another time versus just typing it out down here in the console. So I've just typed it now, but I actually want R to run this, right? I want it to evaluate the code. So I have a couple options. I can do my shortcuts. I could do Control Enter here. I could kind of highlight all that and hit that shortcut, or I can just run the code with this green play button. So I'll do that. Run current chunk. All right. So we got to check that both objects are visible in my environment. What do we think? Do we think we can see those objects in my environment, or do we think maybe we did something wrong? How would I double check?
In the
Yeah,
environment.
exactly. Yeah. So I have these values in my environment. So that's a good way to just like confirm I ran my code, I stored X and Y, they're now ready to use. So if I just wanted, I could also just double check in the console. I could just type X and, I get some values out. So that's good. Same thing with Y. I get some values out. Okay. So clear your environment. We'll check that X and Y are no longer in the environment by typing each letter in the console. What is the result? So let's get rid of the objects here. So I'm going to hit the broom. I'm going to tidy things up. If you hover, it sometimes tells you what the button does. So clear objects from the workspace. It'll ask you, are you sure? All right. So environment is empty. So I'll give us a second. Oh, it's the little broom button here. Yeah, where is the option to clear? Yeah, it's up there. All right. And we'll want to see that they're no longer in the environment. So what happens when I type X and I type Y into the console? What happens? Does anyone get anything out? Yeah, exactly. So if I type that in, it says X is not found. Also, same thing with Y. So that's maybe not what I wanted to do. If that was the case, I could just go back up and run this chunk again. This is why it's kind of nice to save my code just in case, I only have to press one button. I don't have to type it all over again in the console. So hit play. I've got it. Looking good. Okay. So another really handy thing that I tend to use a lot, especially if you're writing a report or writing a paper or something like that. You'll want to know what version of packages and what version of R you're using. And so session info, if you can check that, what's going on in this version of R that you're running. then you can report that back. It might make it a little easier for folks to retrace what you did. So let's try that. Let's do session info. It's kind of fun camel caps here. And we'll definitely need to put on the parentheses there because we're asking it to do something. We're asking it to report back that session info. Hit the play button or do your shortcut and get some of this info. So I am running R version 4.40 and I'm on a Mac. You can see the time zone. Sometimes that's important. All right. And we asked, okay, well, what version of knitter are we running? So, or knit R, however you like to pronounce it. So it looks like I'm running 1.47. It's not my favorite thing here about the different packages. They're not alphabetical, which sometimes makes it a little tricky to find the package that you're wondering about, but usually not too bad. All right. Any questions about any of these kind of? I want to say this is more of like a housekeeping and best practices module here. Any questions about this one? All right. And again, there's additional practice here if you feel confident and want to just get a little bit more practice. So we'll have a couple minutes before we head back to the main session. Yeah, so we could talk pretty briefly about the second part. So set seed is a way to just start the random number generator at the same point. So like I get the same random numbers as Carrie does. They're still random, but we want the same random numbers. And this can be really nice when you're doing simulations or something like that, or just trying to generate some random data to play with. And so you would do that like set seed, and then you could give it any number. But if I do like set seed 99 and run my sample, if somebody else says set seed 99, they're going to get the same sample. But if I give a different number, let's say I do 98, I'm going to get different numbers. Alrighty. So in addition, so we're going to set seed here to 1, 2, 3, 4. So for this question, if you're wanting to check with the key, you would do 1, 2, 3, 4. And then you're not going to use it here when answering that question. And just in case, this is something you want to explore more, you want to kind of make sure that you do every question for extra practice, the key is right there. So definitely feel free to revisit that.